When dealing with electrical upgrades in older homes and ensuring compliance with the National Electrical Code (NEC), there are several key areas to consider. This information serves as a general guide, and it is always recommended to consult with a licensed electrician for specific advice tailored to the home's condition and local code requirements. Firstly, panel replacement. Existing panels should be replaced with a modern panel that meets current NEC standards. All circuit breakers must be upgraded to ensure they have the correct amperage and trip ratings for the circuits they protect. Any old wiring that shows signs of damage or is undersized according to modern standards should be replaced. It's a good practice to install a surge protection device within the panel to protect sensitive electronic equipment from voltage spikes. Secondly, addressing outlet upgrades. All ungrounded outlets should be replaced with grounded outlets to improve safety and accommodate modern appliances. Ground fault circuit interrupter (GFCI) outlets are required in wet locations such as bathrooms, kitchens, and outdoor areas to prevent electric shock. Any exposed or damaged wiring connected to the outlet should be replaced. Consider installing tamper-resistant outlets, particularly in areas accessible to children, to prevent electrical shock. Thirdly, understanding arc fault circuit interrupter (AFCI and GFCI breaker requirements. While AFCI breakers are typically required in all bedroom circuits in new construction to protect against arc faults, they may not be mandated in existing homes. However, it's strongly recommended to install them for added safety. GFCI breakers are essential in wet or outdoor locations to protect against ground faults. If installing AFCI or GFCI breakers, the wiring may need to be upgraded to a minimum of 14 American wire gauge (AUG) copper or larger to ensure proper functionality. Fourthly, handling room additions and circuit expansion. When adding new rooms, new circuits must be installed to accommodate the increased electrical load. If the existing main panel doesn't have sufficient capacity, it must be upgraded to accommodate the additional circuits. If the total amperage of the new circuits exceeds the capacity of the service entrance, the power company should be contacted to upgrade the service. If the main panel is located far from the new addition, consider installing a sub-panel in the new addition to reduce voltage drop and simplify wiring. In addition to these specific upgrades, there are other important considerations. Conduct a thorough inspection of the entire electrical system to identify any other deficiencies, such as loose wiring, corroded connections, or faulty fixtures. Consider upgrading the lighting to light-emitting diode (LED) fixtures to improve energy efficiency and reduce the electrical load. A whole house surge suppressor can be installed to provide additional protection against electrical surges that can damage appliances and electronics. Remember that all electrical work should be inspected by a licensed electrician to ensure compliance with NEC and local code requirements. When considering the NEC, there isn't a single, universally mandated checklist for all old house electrical upgrades. The specific requirements depend on the scope of the work, the condition of the existing electrical system, and the local interpretations of the NEC. However, here is a more detailed breakdown of common scenarios and considerations. Firstly, replacing an outlet. If replacing an outlet, you must ensure the new outlet is properly grounded. If the existing wiring doesn't include a ground wire, options include running a new ground wire back to the panel, installing a GFCI outlet, or using a non-grounding receptacle marked as such. The outlet must be securely mounted in an approved box. Any damaged or deteriorated wiring connected to the outlet must be replaced. It's advisable to check the condition of the surrounding wiring and replace any other old or damaged components at the same time. Secondly, panel replacement considerations. If replacing the main panel, all circuit breakers should be replaced with new breakers of the correct amperage and type for each circuit. The panel should be sized appropriately for the existing and anticipated future electrical loads. All wiring connections within the panel should be checked and tightened. Any damaged or deteriorated wiring should be replaced. The grounding and bonding system should be upgraded to meet current NEC requirements. A whole house surge protector should be installed in the panel. Thirdly, AFCI and GFCI retrofit requirements. SI protection is generally required for bedroom circuits. GFCI protection is required for bathroom, kitchen countertop, a door, and other wet location receptacles. To install AFCI and GFCI breakers, the wiring must be in good condition and properly grounded. If the wiring is old or damaged, it may need to be replaced. If the wiring doesn't include a ground wire, GFCI protection can still be provided by using GFCI receptacles or breakers. Fourthly, adding rooms and circuits. When adding new rooms and circuits, the existing panel should be evaluated to determine if it has sufficient capacity. If the panel is full or doesn't have enough available amperage, it may need to be upgraded. The new circuit should be wired according to current NEC requirements. The new circuit should be protected by AFCI and GFCI breakers as required. The additional load should be calculated to ensure the service entrance can handle the increased demand. Fifthly, when to increase the panel size and contact the power company. If the existing panel is full and doesn't have space for additional breakers, it needs to be upgraded. If the calculated load for the house exceeds 80% of the panel's capacity, it should be upgraded. If adding a significant number of new circuits, it is wise to upgrade. If the service entrance conductors are undersized for the total load, the power company needs to be contacted to upgrade the service. Upgrading the service entrance may involve replacing the meter, service conductors, and the service disconnect. In summary, electrical work must comply with the NEC as adopted by the state, while recognizing that local interpretations and amendments may exist. Here is a more detailed look at the implications. Firstly, the National Electrical Code, NEC, as a minimum standard. The NEC sets the minimum safety standards for electrical installations. States and local jurisdictions can adopt the NEC as is, or they can amend it to include additional requirements. It's essential to be aware of the specific electrical codes in effect in the area. Secondly, checklists and guidance documents. While the NEC doesn't provide a specific checklist for old house upgrades, resources are available from organizations like the National Fire Protection Association, NFPA, and the Electrical Safety Foundation International, SV. These resources offer guidance on common electrical problems in old houses and recommended upgrade practices. Thirdly, the scope of work considerations. The extent of upgrades required depends on the scope of the project. If only replacing a few outlets, only those specific circuits need to be brought up to code. If doing a major renovation or adding an addition, more extensive upgrades may be required. Fourthly, grandfathering clauses. Some older electrical systems may be grandfathered in, meaning they were compliant with the code at the time of installation but don't meet current requirements. However, any alterations or additions to the system must comply with the current code. Fifthly, the importance of professional evaluation. A licensed electrician can perform a thorough inspection of the electrical system and identify any safety hazards or code violations. They can provide a detailed plan for upgrading the system to meet current requirements. They can also help navigate the local permitting and inspection processes. Here are some more detailed considerations for specific old house electrical issues. Firstly, knob and tube wiring. Knob and tube wiring is an outdated wiring method that is often found in old houses. It's generally recommended to replace knob and tube wiring with modern wiring methods for safety reasons. If knob and tube wiring is still in use, it should be inspected by a qualified electrician to ensure it's in good condition. It should not be covered with insulation, as this can cause overheating. Secondly, non-grounded outlets. Non-grounded outlets are common in old houses. They can be replaced with grounded outlets if a grounding wire is present. If a grounding wire is not present, a GFCI outlet can be installed as a safer alternative. A non-grounding receptacle can also be used, but it must be labeled as such. Thirdly, undersized wiring. Old houses may have wiring that is undersized for modern electrical loads. Undersized wiring can overheat and cause a fire. It's recommended to replace undersized wiring with wiring of the appropriate size. The size of the wiring should be determined based on the amperage of the circuit. Fourthly, overloaded circuits. Overloaded circuits can occur when too many appliances or devices are plugged into a single circuit. This can cause the circuit breaker to trip or the wiring to overheat. It's important to avoid overloading circuits by spreading out the electrical load. Additional circuits may need to be added to accommodate the electrical demand. Fifthly, aluminum wiring. Aluminum wiring was used in some houses built in the 1960s and 1970s. Aluminum wiring can become loose at connections and cause a fire hazard. It's recommended to have aluminum wiring inspected by a qualified electrician. If necessary, the connections can be repaired or the wiring can be replaced with copper wiring. Here are additional suggestions expanding on old house electrical upgrades and code compliance. Firstly, comprehensive electrical inspection. Before undertaking any electrical work, it's crucial to conduct a comprehensive electrical inspection of the entire house. This inspection should be performed by a qualified and licensed electrician who can identify potential hazards, code violations, and areas that require immediate attention. Secondly, prioritize safety upgrades. Focus on addressing the most critical safety issues first, such as replacing knob and tube wiring, upgrading non-grounded outlets, and correcting overloaded circuits. These upgrades will significantly reduce the risk of electrical fires and shocks. Thirdly, phased approach to upgrades. Depending on the budget and the extent of the electrical work required, consider implementing a phased approach to upgrades. This allows prioritizing the most urgent issues while gradually addressing less critical areas over time. Fourthly, documentation and permits. Maintain detailed documentation of all electrical work performed, including permits, inspection reports, and receipts. This documentation will be valuable for future reference and can be required for insurance purposes or when selling the house. Fifthly, energy efficiency considerations. While upgrading the electrical system, consider incorporating energy-efficient solutions such as LED lighting, smart thermostats, and energy-efficient appliances. These upgrades can help reduce energy consumption and lower utility bills. Sixthly, surge protection. Install a whole house surge protector to protect against power surges that can damage sensitive electronic equipment. Surge protector should be installed at the main electrical panel and at individual outlets to provide comprehensive protection. Seventhly, smoke and carbon monoxide detectors. Ensure that smoke and carbon monoxide detectors are properly installed or functioning throughout the house. These detectors should be tested regularly and replaced as needed to ensure they are providing adequate protection. Eighthly, emergency preparedness. Develop an emergency plan in case of an electrical fire or other electrical emergency. This plan should include knowing how to shut off the main electrical breaker, having a fire extinguisher readily available, and knowing how to contact emergency services. Ninthly, staying informed about code changes. Stay informed about changes to the National Electrical Code, NEC, and local electrical codes. These codes are updated periodically to reflect new technologies and safety standards. Tenthly, professional assistance. Do not attempt to perform electrical work unless properly trained and qualified. Electrical work can be dangerous and should only be performed by a licensed electrician. Remember, upgrading the electrical system in an old house is an investment in safety, energy efficiency, and property value. By following these guidelines and consulting with qualified professionals, it's possible to ensure the electrical system is safe, reliable, and compliant with current codes.